Hello everyone, welcome to another live coding stream, where today we'll be looking at Hugging Face, and more specifically, we'll be looking at how to use Hugging Face datasets in PerceptiLabs. So today we'll be involving some actual coding, which is rare for us, and I'll show you how to programmatically download a Hugging Face dataset, get it into the CSV format, save the entire dataset, and then use it in PerceptiLabs, and we'll build some model for it. So let's get straight to it and jump into the code. So I already prepared a script here, so we don't need to write everything from scratch. But, oh, and credits to Mukund in our team as well for preparing it, helping me prepare it. So let's start looking at what this is and how it works. And actually, I realized before we jump into the script itself, for those not familiar with Hugging Face, it's a what would you call it at this point? It started out as a repository for NLP models, where you could just download models, you could contribute models, and all that good stuff. So, and now it's grown a bit, so it also includes different data sets. And let me quick jump over to their website. This is the documentation for their datasets pip installation, or rather their dataset program, which you can use to automatically download or upload or handle their datasets. And then they have a repository which looks something like this. You have both models and datasets, and we'll specifically be looking at these datasets. So the ones for image classification specifically, where they have a few, which we'll try downloading one or two and try them out in the tool. So yeah, that's a little bit background to what Hugging Face is. And you can go through here if you want to look at how to set it up and how to use it. But let's swap back now to the code and see how we did it. And this code we'll share, upload to our normal PerceptiLabs repository, so you can play around with it, or it's a little bit bare bones if you want to contribute to it and make it better. That's even better. At the moment, it only handles image classification, or it would handle image segmentation. No, just image classification datasets. So it's working for this case, for what we want to do now, but anything more than that, you would have to expand a little bit to it. But jumping into what the code actually does. So we do our imports as usual. The significant here is to import their datasets so we can download them. Then we'll be loading both a train and a test part of their datasets, which essentially their dataset, say MNIST or CFAR. I think we'll be using CFAR. So we download the CFAR dataset, or we fetch it, and it has two sub datasets, which is these train and test ones. So we fetch these two, and we also fetch what kind of indexes they have, or in this case, they have images and they have labels. And these two will later on become our columns. So we fetch these and we keep them, and then we simply just take all training images, which will be the entire training data sets with key 0, all testing images, which is similar for testing, and we just concatenate it, merge it all together. Then we do the same for labels, So we now have an array full of images and we have an array full of labels. And at this point, we can very easily just throw these into a CSV file and be done with it. The last thing we do though is these labels that you get from Hugging Face, they are in an integer format rather than their actual string format. So to get them back into strings, which we want in PerceptiLabs, we want to know if it's a cat or a dog, we want to know if it's a 0 or a 1. We and do this mapping. So here we just convert it. So we have essentially 0 means dog, 1 means cat, etc., etc. And this we'll be using later on when we create the CSV file. So we get the correct label in there. Finally, we have all the data we need, and we can just create the folders. Then we'll just we create our folders to store the images in, and then we'll just loop through all our data to first create the images, and then lastly, create the images and throw them into a new array we call files, which contains the file paths. And then finally create all the labels and throw them into a similar array. So we have a really correct mapping. So we have both our file paths and our labels in nice and tidy little arrays, which we can throw into a Panda data frame and finally create a CSV file from it. So let's see how this one would look like in practice. I realize I haven't opened up an icon environment yet. Give me 1 second and I'll do that. Alright, let me share what I'm doing as well. Here we go. All right. So I have a new environment for this where I just installed all Hugging Face dependencies, and then I'm just gonna jump into the code where we can run the download Hugging Face dataset script, which was one I just showed here. Should Python, not pip. Oh, and one last thing in the code. Let's see if you guys can still see this with the... Let's move this one over a little bit. So we also added, again, credits to Mukund, we also added some arguments so you can set exactly which dataset and path you want. So which dataset you want to download from Hugging Face. And this will be exactly the names that we saw on the website before. And then just where you want to download it to on your local, and where you want to create the PerceptiLabs version of this dataset. So we're gonna use the CFAR10 dataset. It's a little bit more fun than the MNIST one. So we'll just enter in the CFAR10 and the path can just stay like that. And to not completely choke my internet, I pre-downloaded them before. So they're just using cached version. Otherwise, it would now show you the download. I should just take another second and we'll have our folder and our CSV file. There we go. In other cases, I wish I added more prints in everything I code. So let's jump over to the folder and see how it looks like. So here's the folder, the code folder, which we had the code inside. And we can see now here, C410 folder has popped up. We can go in here and we can see the data CSV file and the images. And the CSV file will look like a standard PerceptiLabs CSV file, or any CSV file which maps images over to targets. All right, so that's the coding part. Then now we're ready to start actually using it. So we can jump back into PerceptiLabs and start creating a project. Oh, and with the release that's coming out hopefully today, you'll also have these public datasets. So you have a bunch of datasets which you can download. And we have the CFAR already here, and we'll be adding more Hugging Face datasets as well. So you can do this way to get the dataset downloaded if there's a specific one you have, but otherwise you'll probably find a few good ones here as well. But let's jump over to local, and I don't think you guys can see me choosing the file, but let me just do that quick. There we go. That's the CFAR CSV, which we just saw. We go images as inputs as normal, and the targets, well, they become our targets. And I don't think we need to do any pre-processing to it, so we'll just create the model. This one's a little bit larger, so it might take a second or two to create it. There we go. All right. And now we can use it just like any other dataset. So let's try running it and see how well CFAR performs on a very simple CNN. And then we can maybe throw in a VGG to it, or see what else happens. And just before I jump over, or completely jump away from the Hugging Face part, the names which you copy in is exactly the names as these datasets. So I just took the CFAR10 here. But it would be really easy to throw in food 110, 101, for example, or CFAR 100 if you want something with a little bit more classes in it. Or the fashion amnist, which is a fairly popular one as well. But let's get to running the actual model. So we can start running it with just 5 epochs, see how that works. Again, it's a little bit larger, so it might take a second to spin up the training for it as well. Here we go. And if we swap over to targets, we can see how it's progressing. You can also take a look at the gradients. They're not flat. That's good. I also don't know if I showed this last time. We have this performance tab now, which you can look at, which is apparently currently empty. There we go. Right, I'm looking at validation. You can see precision recall and F1 here. So let's jump back to this one when the training is done, and we can see how well the model performed in this aspect as well. This is when I realized I probably should have ran it on slightly less epochs. It is a 60,000 images datasets after all. Just taking a look at the gradients through the different layers to see if any of them actually flatten. But they look fine, meaning that it's still training. It is a very small model for such a large dataset though. So it might not do so well. Maybe it was too large for me training the entire thing while streaming it. Or no, it keeps training. All right, let's ignore that ever happened and keep watching it. Oh, just give it a second until it's done. There we go, we keep track of it here. There we go. Now it should no longer complain at me, I hope. All right, so we got 60% accuracy. Not awful, maybe not the best. And thank you very much, Vera. It's the designers did a great job on the UI changes. But yeah, and but we can see that the model is not fantastic on this. It's confusion matrix is always a good way to see how well it predicts. And this is a confusion matrix, just a flattened one. Ideally, you want each of these columns to be a single color, the correct color. But currently it's just mix-matched everything, which we should also be able to see here in the precision and recall. So if we look at the, I usually look at the validation recall and precision because it's, well, it's similar to looking at the validation accuracy. You get more realistic or real world numbers that way. I can select all of them and nothing is 0, so that's good. And we also have the recall, but all are around 0.5. And what this means is for recall, it finds about half. Take airplanes, for example. It's or better, automobiles, cars. It finds 50% of the amount of cars it can find. So 50% of the cars, it just classifies as something else. It might be an airplane, it might be a cat. We don't see that here. That we can see in the confusion matrix. But that's what recall says, meaning that if you want to be very, very particular with finding every single sample, let's say, for example, you're looking at COVID tests, and you want to be sure that every time that you don't miss any COVID tests, there is no COVID test which should have been true, that actually gets classified as false. Then you want the recall to be as high as possible. The precision, on the other hand, the precision tells you how well you find the actual samples that you do find. So out of these 50% samples we find for cars, let's see if we can find cars here. Yeah, so 77% of those cars we find are actually correctly classified. I hope anything of that made sense. There are some good links on precision recall out there, so look it up. But it's a great way to know how well your model performs for specific classes. And if you want to dig a little bit deeper into the model, this is a great way to do it. The last thing we can do real quick, we could go through the evaluate. The bug we just got before, it's a known bug which we're currently in the process of fixing. It's not fixed in this branch though, which means if I run the test, there's a good chance that I'll hit a bug and it just won't work. But we can deploy it and try it on Gradia and see how that runs. And thank you very much, Tavis. Glad you like it. So deploying it like this, we'll actually be able to try sample by sample what it classifies them as. So if you have some testing data which you did not load into PerceptiLabs, you can look through them this way and see how well it actually classifies them. Or you can use the fast API instead to get the a much faster result. We can take a look here, and I don't think you can see what I select, but we can throw a code picture in and we can clearly see that that is a cat. So that works as intended. But if we try an actual C4 image, a truck, for example, we'll see truck. So it classifies, well, it did have 60% accuracy, so it should get hopefully around 60% of this correctly. That is an airplane. And maybe if we do this airplane. So you can play around like this. I think we're gonna make it as well, so it just doesn't only show the label. We currently have that because it's very quick to just get the correct prediction. You don't need to do any post-processing. But the downside is you can't see how confident it is that it's a car we're looking at. So that's something that's likely coming in updates. But yeah, that was both the new version that's coming out soon, but Hugging Face and how you can use Hugging Face datasets in PerceptiLabs, specifically for image classification. And we only have 5 minutes left, so I don't think I'm gonna attempt to train a VGG. That would probably take closer to 10 minutes. But considering how small this model was, we did get some decent results. So I think I'm gonna call the stream here. If anyone has any questions, I'll hang back in the chat a bit and we'll be happy to answer them. But otherwise, have have a fantastic day, and don't forget to join our forum if you haven't yet. We're doing a lot of cool things there. Take care, everyone.